Bismillahirrahmanirrahim. The title of this lecture is Vector. In this lecture, we have to explain vector quantity and scalar quantity, example of vector quantities and scalar quantities with notation of vectors. So, what is scalar? From the diagram, we see that scalar has only magnitude. Here, if we see that vector, so vector has magnitude as well as direction. So first we have to explain magnitude. Magnitude is uh, number number plus number plus unit is called magnitude. Is called magnitude. So the scalar quantity has only magnitude, but vector quantity has magnitude as well as direction. Now example of scalar quantities. Distance is the example of scalar quantity, speed, time, mass. But the example of vector quantities is displacement, velocity, acceleration, force, momentum, etc. Now we have to define uh, scalar quantities deeply. A physical quantities. What is physical quantities? Physical quantities means those quantities which is measurable. A physical quantities which can be described completely by its magnitude only and does not require direction is known as scalar quantities. It obey the ordinary rules of algebra. Now, vector quantities. The definition of vector quantities is a physical quantities. This means that vector quantities and scalar quantity both must be physical quantities. A physical quantity which required magnitude in a particular direction when it is expressed is known as vector quantities. Means for vector quantity we need magnitude, we need magnitude as well as direction, as well as direction. But for scalar quantity we need only magnitude. Now vector quantities must obey the rule of vector algebra. A vector is represented by a line headed with an arrow. Its length is proportional to the magnitude. Let A is a vector. A is equal to PQ. P is the initial point and Q is the terminal point. Magnitude of A is equal to A magnitude. Expressed is like this. Thank you so much for watching this video. Please subscribe the channel for more informative videos.